Okay, we're going to go ahead and get started on section 1.5, linear inequalities. So we're going to talk about open and closed intervals. A lot of these ideas you have seen in algebra 2. So the difference between a parenthesis and a bracket here is what we're focusing on. So an open interval, which uses the parenthesis, is all numbers between two numbers, but not actually including those numbers. So that's what an open interval is, and it uses the parentheses. A closed interval uses brackets, and it's the same thing. It's all the numbers in between, but it also includes those endpoints A and B. So there's a difference in when you draw them, what you're going to end up actually using. So when we're going to draw inequalities in an open interval, you're going to use an open dot, where in a closed interval, you're going to use a closed dot. Okay, so it says graph each interval on the number line. So between -2 and 3. So if this is 0, your middle, 1, 2, 3 tick marks, you should label that. It's an open dot. And then I also have -1, -2 to the left of 0. It's an open dot because it's a parenthesis. And this is saying all the numbers from -2 until 3. So that's where you want to shade. So sometimes I draw my picture like that. It's kind of up to you. I'll draw it a couple different ways and you can kind of see how you feel comfortable, but those dots should definitely be open and I should definitely see some shading between -2 and 3. Next one. So this is saying between -1 and 10, including the numbers -1 and 10. So sometimes I see students labeling -1 and 10 is to the right of it. That's fine if you didn't mark your 0, but I definitely should have the endpoints. And then in another color, maybe I'm going to go ahead and say -1 is a closed dot, 10 is a closed dot, and maybe you want to shade like this and you like to shade on the line. That's fine too. It's still showing me that there's closed dots and you're shading in between. Number 3, it's kind of that same idea here, where you're going to go ahead and label. So we've got 2 to 5. So there's 2 and 5 is on the right of it. You have to have those numbers in the correct order for a number line. And then when I go to color it, the 2 is an open circle because it's a parenthesis. The 5 is a closed, and this is saying all the numbers from 2 to 5. So some sort of shading between there. So those are just 3 different options of how it could look, but I definitely should be able to tell if things are open and closed. So be really careful writing with the iPad and closing those dots. Please make sure I can tell the difference. We also have something called unbound intervals. Unbound intervals are when we're going to be using the infinity or the negative infinity symbol. So that means they're going to be going towards one of the arrows, either towards negative infinity or towards infinity. So if you look at a number line, negative infinity is going by the arrow pointed to the left because it's continuing to go to the negative values, and the arrow all the way going to the right is towards your positive infinity because those numbers get bigger and bigger and bigger. So they're unbound because they continue to go on forever. So you will have an arrow in your drawing as well. So again, I'm going to show you a couple different ways you can draw it. So this is from 4 to infinity. So here is 0. So if you want to mark your 0, that's fine. This is the number 4. So again, this is saying from 4, it always goes smallest to largest. So the smallest is 4, the largest is infinity. So at 4, I need a closed circle, and it's going towards infinity here. So I need an arrow because it's continuing to that infinity sign. So same thing with number 2. I'm going to show you how I see some students write it. So this is from negative infinity until 3. So we know it's going to shade to the left up until 3. So it's okay if you just mark 3, but you need to make sure that your arrow, which is going to be first an open dot at 3, and then you're going towards the left. So it's something like that. Or if you like to, some people I know like to scribble their shading like this, that's fine too. But I should see an arrow towards negative infinity up until 3 with an open dot because it does not include the number 3. 3 is not a solution. Again, the infinity symbol is not a number. It's just telling you that it keeps going on and on and on. So let's continue to look at that. We're going to talk about interval notation, set notation, and number line. The only thing different here for you guys is set notation, because again, you guys have seen the interval notation in Algebra 2. So set notation corresponds with interval notation. You should be able to write either way. So I'm going to do an example of them because a lot of times it's easier to tell something when you look at an example. So A, we're going to pretend is 2. So if we have 2 until infinity. Set notation, you should be able to write, you're going to keep the x the same. That means x exists such that, that's what that one bar means. That little bar means such that. So now they're going to do some explaining after that. Such that x is greater than 2. So you're pretty much just graphing the inequality x is greater than 2, which you've been doing since Algebra 1. So again, up to you if you want to draw the 0, 1, 2. So that's where my 2 is. And then I'm going to go ahead and shade. X is greater than 2. So I want to go towards greater. So it's an open dot and to the right. Again, it's an open dot because it's greater than. It does not say greater than or equal to. And you can also tell by the parenthesis. Also notice by the infinity signs. Infinity signs will always be a parenthesis. Same with negative infinity. You will never have a bracket around an infinity sign, okay? Anytime you use infinity, it's a parenthesis, always. I cannot stress that enough. All right, in our second example, I'm just going to keep with 2. What happens if we have a bracket from 2 to infinity? Then that would look like that. X exists such that x is greater than or equal to 2. So the only difference here is that when you graph this, 2 is part of the solution. So you would need to have a closed circle at 2, but it still needs to head towards infinity, and infinity is to the right. All right, let's look at another case. What if we are talking about negative infinity until 2? Notice how negative infinity is on the left. I should never see a negative infinity on the right side because you always do the smallest number to the largest number. So negative infinity is clearly smaller than 2. And in set notation, you would do these funny little brackets. X exists such that x is less than 2. So this time we're doing the less than sign. So you're going to, since it's less than, we want the smaller number. So once again, we've got 0, 1, and 2, but now we're shading to the left. It is a parenthesis at the 2, so it's an open circle to the left. Looks like that. All right, let's take a look at the next case. The next case, again, negative infinity until 2, including 2. So it's got a bracket. So in our set notation, the only difference is now we're going to use less than or equal to 2 because we want to use a closed circle. So very similar to the one above, except I'm going to use a closed circle at 2. And I'm heading to the left towards negative infinity because, again, negative infinity is on the left, positive infinity is on the right. Okay, the next one, negative infinity to infinity, is all real numbers. That's every number that's possible. That's real, at least. So if you wanted to write that in set notation, that's saying, and really they did it the opposite way. So typically you're going to see it written like, let me show you. X exists such that X is a real number. So usually you see that X in the beginning with the slash. They did it the other way around, so you can just cross that off. But that's saying X exists at a real number. So that funny looking R, that double-lined R, that's a special symbol for being real, a real number. You know, remember imaginary numbers from Algebra 2? This just means it's a real number. Eventually, we will talk about imaginary numbers as well. So if you were going to highlight all the real numbers, you would highlight everything in the number line, all real numbers. If you leave it blank, that does not mean all real numbers. That means no numbers. So make sure that you shade for everything for all real numbers. Last one, let's do an example where we have negative infinity up until 0. Well, it's not a great symbol there. There we go, it's a better parenthesis. Union 2 until infinity. So that's what that U means. That U right there means union, union, union. Which makes sense, U for union. It typically means there's going to be a gap in your picture, typically. So I'm going to put that in kind of like quotes marks. So for our example, with the numbers that I gave you, we're going to say X exists such that X is less than 0 or X is greater than 2. Okay, so I've got 0 here and I've got 2. And it's first saying X is less than 0. So I have an open dotted 0 and less than is to the left of it. And then I also have or X is greater than 2. So it's an open dotted 2 and to the right. So typically you'll see some sort of gap with an or statement. So it's either on this side or it's on this side. It's either in this inequality or it's in this inequality. That's what your or means. So we're going to practice some translating. I'm going to help you with these. You will do some examples shortly. It says translate the phrase to interval notation. The set of all numbers less than 3 or greater than or equal to 8. So the set of all numbers less than 3. When they're saying the set of all numbers, they're talking about X. Okay, so in your mind you can just say X is less than 3 or greater than or equal to 8. So we're talking about X here. So X is less than 3 or greater than, so or X is greater than or equal to 8. That's what that's saying there, okay? So we're going to go ahead and put our answer multiple ways. This is the inequality answer, which you guys have been doing since Algebra 1. You've known how to write an inequality. The new thing is a set, so we're just going to go ahead and practice how you would write it as a set. You would just go ahead and put the funny little brackets, X, such that X is less than 3 or X is greater than or equal to 8. And the actual answer is interval notation. I just wanted to practice the other ones. So for the interval notation, that's where you're using your parentheses and brackets. You're going to need 2 for the or statement, okay? So sometimes if you get stuck here, it's really helpful to draw a picture for yourself. I have found students say, oh, it makes so much more sense when I look at a picture. So what you're doing is X is less than 3 or X is greater than 8. This is your picture. So when you go from left to right, remember this is negative infinity and this is infinity. When you're going to go ahead and write the answer here, and I'm going to do it in a different color so it stands out. We're going from left to right. The first thing I see is negative 8 and, or I'm sorry, whoa, looking too quick, negative infinity. It goes from negative infinity, which I put a parentheses, and it's shaded up until 3. At the 3, it's an open circle, so I use a parenthesis. Then there's a gap, so I'm going to use a union. Then there's the 8. It's in closed, it should be, because it says or equal to 8, so that's got to be a closed circle. So I'm going to use a bracket because it says greater than or equal to, and it heads towards infinity, and infinity gets a parenthesis. So notice how I literally took each part. I went from the negative infinity until the 3, and then the 8 until the infinity. I just went from left to right, and that's how I listed the numbers, and then I used the correct parenthesis or bracket as needed. Okay, let's try another one. It says translate the phrase below to an inequality notation. So here the final answer should be an inequality notation, okay? We might practice some of the others, but your final answer should be an inequality notation. The set of all numbers that are less than or equal, or no, doesn't say or equal, that are less than negative 13. So let's take a look. The set of all numbers, we already talked about when it says the set of all numbers, it's talking about x. So x that is less than negative 13. X that is less than negative 13. So that's your answer. That's the inequality notation. I'm going to box my answer above. So that's your inequality notation. If you practice your other ones, which I know it doesn't ask, this is notes, so I just want to get a little bit of practice in. If it asks for the set notation, very easy. You add the extra little squiggly bracket. You're going to say x such that x is less than negative 13. If it does ask you for the interval, just for practice, again, the interval, x is less than negative 13. Less than is going to the left, and it's an open dot. So in order from left to right, you would be going negative infinity until negative 13, and they both would be parentheses. Again, I boxed the answer that they're looking for, but I want to make sure you're familiar and good at writing both of them. All right, the next set of problems, we've got 4 problems here, is solving inequalities. So I'm going to do a few, and then you are going to do one as well. So I'm going to do number 4, and then I'm going to have you do number 3. Okay, so number 4, treat an inequality sign. You know, you have your left side and your right side, so you're going to solve it just like normal. So you're going to have to subtract 5 to each side. Keep my inequality sign. 13 minus 5 is 8. My next step, which I'm going to write out, and hopefully you remember what's going on here. When you multiply or divide by a negative number, you need to make sure that you flip the sign. Okay, really important there. So you have to flip the sign so it ends up being x is greater than or equal to negative 2. So I'm going to go ahead and write that and then highlight it. So remember that rule. When you multiply or divide by a negative number, so the number is negative on the bottom, and it has to be to both sides, you have to flip the inequality sign. So important that you do that. Otherwise, your arrows are going to be going the wrong way. So I'm shading that because that is so important that you do that. So our answer is x is greater than or equal to negative 2. It says write the solution in interval notation. Okay. So in interval notation, x is greater than or equal to negative 2. I like to look at the picture first. So if this is negative 2, x is greater than or equal to it, so that means it's going to go towards infinity. So I'm going to go ahead and do a closed dot at negative 2. I'm going to color it in as best as I can, and it's heading towards the right. So my picture, and again, you're doing these from left to right. So I'm first going to name negative 2 and then infinity, okay? Because you want the smallest to the largest number. So my answer is going to be a bracket at negative 2 because it's closed until infinity, and all infinity signs get a parenthesis. So that's the interval answer. Okay, for this next one, for number 3, because you have been solving inequalities since Algebra 1, I'm going to have you stop. And I'm going to have you try this one alone, and we're going to see how you do. All right, welcome back. So hopefully when you went to solve this, you subtracted 3 from both sides, which gets you to negative 24. And then when you divide by 8, you should not be flipping your sign because you're dividing by 8. You are not dividing by a negative number. You're dividing by 8, so you do not flip your sign. So when I go to graph this, here's 3, and we're saying x is greater than 3. So we want to head towards the infinity sign because it's greater than it, okay? So an open dot because it's not equal to, and to the right. So an interval notation, because again, you should kind of be saying from 3 to infinity, smallest number to largest number. And we know 3 is obviously smaller than infinity. So our final answer is going to be 3 with the parenthesis infinity with a parenthesis. So hopefully that's what you typed in because you have access to those buttons on your computer. All right, let's take a look at, I'm going to skip again. We've got 2 problems left. I'm going to take a look at number 6. So for number 6, we have a and problem. So you can draw 2 sets of lines to help keep your work organized. This time you're going to have to do whatever to get x alone in the middle. You have to do it to all 3 parts. So to undo dividing by 5, the first thing you should do is multiply by 5. When you multiply by 5, you have to do it to all 3 parts. Okay, so dividing by 5 and multiplying by 5 cancels in the middle. So in the middle, you are going to be left with just 2x plus 3 because we're trying to get x alone. Bring down the inequality sign. 6 times 5 is 30. Negative 7 times 5 is negative 35. Again, you're undoing things from the middle so you can get x alone. The next thing is to subtract 3. Again, you have to make sure you're subtracting it from every side. A lot of times I see students only do one side, and that's how they end up with the wrong answer. The inequality signs come down. Negative 35 minus 3 is negative 38. 30 minus 3 is 27. And then I'm going to divide by 2. Make sure, again, you divide 2 by everything. And I know I'm writing on top of the other notes. That's okay. I'm going to write my answer over here. So I still have x in the middle. I don't have to worry about flipping my signs. Negative 38 divided by 2 is negative 19. And 27 divided by 2, you can keep like that. Or as long as you don't round the answer unless it tells you to, 27 divided by 2 is 13.5. So up to you. That's the inequality answer. I like to look at it visually next. I need to label negative 19 is on the left and 13.5 is on the right, or you can use the 27 over 2. Totally fine. This is saying x is greater than 19, so I'm going to the right, and it's less than 13.5. So this is an and problem here, okay? So if you need to refer back to an and problem in your notes, that's the one you're looking at. All right, so let's go ahead and shade. So it's an open dot at 19, but a closed dot at 13.5 because it's underlined. And it's greater than negative 19, but less than 13.5. So it's between. Typically the ands are shaded in between. So our interval notation, again, you're going from smallest to largest. The smallest is negative 19, the largest is 13.5. At no point do you have an infinity sign that you will be using. So negative 19 is a parenthesis because it's an open dot. 13.5 is a bracket because it's a closed dot. So that's your interval notation. All right, I'm going to have you go ahead and try one more. So stop and try number 5. All right, so in number 5, you should be just normally solving it by distributing here. So 5 times 2 is 10. 5 times x is 5x. Next one, 2 times x is 2x, and 2 times 7 is minus 14. And then you're just moving things around to get x alone. I like to keep x on the left side. You don't have to. So what I'm going to do is I'm going to subtract 2x, which is going to get me 10 plus 3x is less than or equal to negative 14. Then I'm going to go ahead and subtract 10, which now gets me to 3x is less than or equal to negative 24. And now I divide by 3, and x is less than or equal to negative 8. Now you can solve it with x on the other side. Just make sure you're clear when you divide or multiply by a negative number to both sides, you do have to flip the sign. I did not have to. So our pictures should all look the same as well. So if this is negative 8, x is less than it. So it's going towards negative infinity. So it's in closed dot because they underlined it. and it's going to the left. X is less than or equal to -8. So again, remember, this is where your negative infinity is. So you're going from negative infinity until 8, smallest to largest number. Negative infinity is the smallest number, so it must go on the left side. And then it's -8, and it's a bracket. It's always smallest to largest. And there's your answer. So hopefully you've got that one correct. All right, guys, thanks for listening to me, and I will see you in class.